Hello everyone. Let's take a look at the exponential smoothing and trend adjusted exponential smoothing. This is a formula to calculate the exponential smoothing, where we basically use the previous forecasting result and forecasting error to calculate the forecasting of next time period. Now, the problem for the exponential smoothing is when we first set up the forecasting, the first exponential forecasting actually we do not have a previous forecasting to rely on. So the question is, what should be the first forecasting in the exponential smoothing? We basically take a look at it. When we try to make the first forecast f1, now a0 is extra data and the smoothing constant alpha is given. But what is this f0? So this f0 usually is the result from naive forecast. We just assume that previous extra data will be the forecast for the next time period. Now let's take a look at how we conduct the exponential smoothing process. Now we have the following demand from period 1 to 7, and that I will show them one by one to demonstrate how the exponential smoothing is calculated. Here we are required to use exponential smoothing with alpha equals to 0.1. So when we have the first time period demand, this demand will be used to forecast the next period. That is what we mean. The first forecast is not based on calculation. The first forecast is just a result from the naive forecast. Now after we have forecasted the demand for period 2, we can receive the real demand. And now we have one forecast and one real demand. We can use these two numbers to calculate the forecast of next time period. Now this forecast, we see the alpha 0.1 is used to calculate the adjustment based on the forecasting error. The forecasting error basically is the difference between the real demand and the previous forecast. And of course, we will have the real demand generated or occurred after the observation after the forecast has been conducted. And similarly, we can take one more step to calculate the next time period. Now we see the forecast for period 4 is based on the forecast of period 3, which is 41.8, and the actual demand of period 3, which is 33. Of course, the smoothing constant alpha is used as well. And similarly, the whole process can keep going on and on and on. Now, for the exponential smoothing, what I want to point out is, first, we cannot estimate for the first time period because now we do not have any forecast at all. So we usually the first time period demand will be used as the forecast for next time period. That is why for the exponential smoothing, we always start from the second time period. We cannot start from the first time period. Second, not like moving average or weighted moving average. Now, assuming we have the demand from time period 1 to 7, and we are expected or we are required to use exponential smoothing to forecast or predict demand for period 8, we cannot just use the original demand to calculate the forecast for period 8 at all. We need to starting from the first forecast, like what we did here, and gradually after we get the exponential smoothing forecast for every single period up to period 7, and then can we take one more step to calculate the forecast for period 8. So it doesn't matter how many periods we already have, we should always calculate the forecast from the beginning. That is how we calculate the exponential smoothing. Now, the smoothing constant alpha basically will affect how the forecast result changes with the real demand. Or this is a parameter that basically will determine how responsive the forecast result will be. Now we take a look at this chart here. We have the forecasting with three different smoothing constant, alpha equals 0.1, 0.5, and 0.9. We can see the smaller the smoothing constant is, the smoother the result will be. And the larger the smoothing constant is, then the more responsive the result will be. Now we can see when alpha equals 0.1, the forecast result is pretty flat, and it didn't change with the significant change of the actual data. On the other hand, well, when alpha equals to 0.9, we can see it always change with real data, which means the forecasting model itself is very responsive. Why? Because the smoothing constant alpha basically determines how influential the most recent data will be. When this number is pretty big, it means that 90% of the forecast is contributed by the most recent data. That is why it is very, very responsive. Sometimes, if the original data has a very strong trend, then the exponential smoothing may not be able to describe or make the forecast properly. As we shown in this example here, the blue line is the extra data which shows a very strong increasing trend. Now, no matter how we adjust our alpha, we can see the forecast of exponential smoothing is always lagging the real demand. So that is pretty much the case. Now, the question is, if there is a very strong trend in the data, what should we do? That is where the trend-adjusted exponential smoothing is introduced. If we take a look at the formula of trend-adjusted exponential smoothing, we can see it includes two parts, S and T. S is a part that is calculated similar from the exponential smoothing. Well, in the trend-adjusted exponential smoothing, we have an extra part which is the T. This is the part that we estimate the trend. So for trend-adjusted exponential smoothing, basically the forecasting includes two parts. One is a standard estimate from exponential smoothing. The other part is an estimation of the trend itself. And the forecast is the sum of these two parts. And for these two parts, we have two different smoothing constant. Alpha is the one that we used for the exponential smoothing, and for the trend estimate, we have another smoothing constant, beta. Now, to do the trend adjusted exponential smoothing, we now need two initial data instead of just one for exponential smoothing. We need an initial estimate of the trend as well as the first forecast. And of course, the first forecast usually is the result from naive forecast. But how about the initial estimate of trend? Let's take a look at an example and see how the trend adjusted exponential smoothing is calculated. Now, given following demand data, please forecast period 11 demand with trend adjusted exponential smoothing. assume that alpha equals zero point 0.3 and beta equals zero point 0.2. Now remember, as we talked before, it doesn't matter which time period we need to estimate. For the exponential smoothing, we should always calculate from the beginning. Basically, for this example, we should calculate from ideally from period 2, 3, or 4. But since we need to estimate a trend, because this is a trend adjusted exponential smoothing, so we may ignore or pass the first 3 or 4 time period in the forecasting. So basically, if you remember, we need to have an initial guess or estimate of two parameters or two data, which is the trend and the first forecast. Now, let's see how we calculate the initial estimation of the trend. We use the first 4 periods data, which is period 1, 2, 3, 4, to calculate the initial estimation of the trend. We see that from period 1 to period 4, the value of the demand increased from 500 to 528. So the difference is 528 minus 500, which is 28. However, this 28 change actually spans over 3 time periods, from 1 to 2, 2 to 3, 3 to 4. So we divide by 3, give us a number of 9.33, which means for this 3 time period, the increase of the demand is 9.33 from one time period to next time period. So this will be our first or initial guess of the trend. And then we conduct the first estimate or the forecasting for time period 5. Here we remember the forecast for the trend adjusted exponential smoothing includes two parts, the exponential smoothing estimate and the trend. Trend is what we calculated or estimated as 9.33. And for the exponential smoothing estimate, we use naive approach as the initial estimate or initial forecast. Now, we are estimating time period 5, so we use the demand of period 4, which is 520, as the estimate of ST. So we have the initial estimation of period 5 demand equal to 528 plus 9.33 equals to 537.33. Now, if we look at this table here, this shows us how do we conduct or calculate the trend adjusted forecast ST and TT in each of the time period. We summarize the sequence of the calculation. We estimate the trend first. With this given trend and a naive approach, we can estimate the first forecasting number. With the forecasting number, we can estimate or calculate the first ST. Now, ST plus TT will give us TAFT, which is a trend adjusted forecast. And with this number given, we can calculate the corresponding ST and TT, and then we move on to next step to calculate the next forecast number. So this is the basic sequence of the calculation in the trend adjusted exponential smoothing. Now we look at the plot here. This plot basically shows how the trend adjusted exponential smoothing fit into the actual data. We can see compared with the simple exponential smoothing, this method actually gives us a much better estimate of the demand.